All right, good morning or afternoon, depending on when you're watching this. This is Miss Figueroa, and today is October 30th. We're going to be doing some notes on writing equations. At the very top, you see that it says day 1. This is going to go on for a while. The main topic of Algebra 1 are equations. So we're getting into the process of writing them given various forms. So if we're given a word problem, if we're given a table, a graph, anything like that, we should be able to write our equations. So right here it says, given an equation in slope-intercept form, graph the line. So remember that slope-intercept form is the one we're probably most familiar with. And that's that y equals mx plus b. M is our slope, and b is our y-intercept. So that's why we call it slope-intercept form, because we have both of those things in the equation. So m is our slope. M is the one with the x. So this is my m, and this is my b. So my slope is -3, or we're used to seeing our slopes as fractions because we know it is rise over run. And it's going to be a lot easier if we have it as a fraction. So -3 is a whole number. Any whole number, if we want to write it as a fraction, we just put it over 1. So -3 over 1. It's the same thing as just saying -3. And then our y-intercept is going to be -1. Remember, for our y-intercepts, we have a 0 for x and then a number for y. So we're going to have our y-intercept at 0, -1. So then it says to graph the line. So we're going to go over to that graph, starting with the y-intercept. So on this y-axis, the up and down axis, we're going to go down to -1 and plot a point directly on that line. And then using our slope, we got rise over run, but it's negative. So when we have a negative slope, we're going to go down that number and still to the right. So down 1, 2, 3, and over to the right 1. Down 3, over to the right 1. Now the problem is it's going to be really hard for me to graph this continuing that line because I don't have anything to the left of my y-intercept. So whenever I want to go to the left of the y-intercept, we have to go opposite. So left of y-intercept means opposite of the slope. So I'm not saying flip it and do 1/3. I'm saying we're going down and then to the right. So now I'm going to go up and to the left. So up 3 and to the left 1. So you see what I mean by opposite. So up 3, left 1, up 3, left 1. And your line should make sense. If you are graphing something and you go, whoa, 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 what in the world did I just do? Then check on your slope. That's usually where we're going to see those mistakes happening. Remember, these are linear equations. They should make a straight line. And it is incredibly difficult on this tablet that I'm writing on to make a perfectly straight line, but if you put a straight edge up next to all of your points, they should align and make a perfect line because these are linear. So that is the graph of -3x minus 1. We see that it has a negative slope and the graph reflects a negative slope. Our line is falling, so that is an indicator that we probably did that correct. So it says, now let's do the opposite. Given a graph, write the equation of the line in slope-intercept form. So we got steps here. The first one is find the slope. The second one is find the y-intercept. And then we're going to put them together, y equals mx plus b. I typically will find the y-intercept first. So on mine, you're going to see that that's my first step. So I'm going to find my y-intercept, and we find the y-intercept it's going to be the only, unless it is a straight up and down line, dot on the y-axis. So the only dot, the only point on the y-axis right here on number 1 is right there at 4. So now using that y-intercept, I can find the slope. So now that's my second step. I'm going to go down 3 and over 1, and I see that makes a point. So when we're finding the slope, we're trying to see where is my next point. So another way I could have done that is looked at my line and said, well, where is it crossing perfectly? And we'll say right here, there's a point. So I'm going down 3, so that's minus 3, and to the right, 2. So then my slope, rise over run, is negative 3 because we fell 3, we went down, and then 2 because we went to the right 2. My y-intercept that we found was 4. So I have my m, I have my b, so then I can write my equation, and y equals m negative 3 over 2 x plus b 4. So we just wrote, we just wrote an equation given a line. Whoops. In slope-intercept form. So we're going to do the same thing on this second one. So remember, my first step is going to be to find the y-intercept. If you want to find the slope first, that's perfectly fine. So my first step is looking for whatever point is crossing the y-axis. There should only be one. I see mine is happening right at the origin. So my b is 0. And then I'm going to find another point, so anywhere that it is crossing perfectly. And I see that it's not quite here and not quite here, but it would be right there. And same thing on the left, it's not quite crossing, not quite crossing, but it would cross perfectly right there. And those look like they're equidistant from the origins. So let's see when we count our slope. It's going down, so 1, 2, 3, 4, 5, down 5, and to the right 1, 2, 3. So then let's see if we go the opposite way, from this point all the way up here down to the origin. We go down 1, 2, 3, 4, 5, and over 1, 2, 3. So they're matching. That means I did this correctly. That is my slope. So my slope is down 5 and to the right 3. So negative 5 over 3. I have my m, I have my b, so I can go ahead and write my equation. Y equals m x plus b. Now the question is, do I ever need to write plus 0? And the answer is no. I don't ever have to say 1 plus 0. I would just say 1. If I told you I have $3 plus $0, you would look at me like I was crazy because I just need to say I have $3. So the same thing happens when we're writing our equations. If it's plus 0, we don't need to say it. It is assumed that there's plus 0. So anytime you see a linear equation without a b. So you got negative 5 over 3x, then we've got plus 0 is implied on the end there. So our origin is our y-intercept. Then on number 3, remember we're finding the y-intercept first. So where I'm crossing that straight up and down line is right here at 2. So my b is 2. And then I'm looking for when's the next point that I'm crossing. It can be anywhere on the graph. So I see one here, I see one here, and I see that there would probably be one there. And if I look at all those points, they look equidistant from the next one. So I can count my slope from this point to this point. So I'll go up 1, 2, 3, and over 1. So up 1, 2, 3, over 1. Now in the problems we did before we were writing the equations from the graph, if it's 3 over 1, that's just 3. So our slope is 3. So then we have both the m and the b, so we can go ahead and write our equation. Y equals mx plus b. So 3x plus 2 is our equation that gives us that line. And I see that it has a positive slope, which is different from the first two that I did. And it should look different on the graph, and they do. So the first two had negative slopes, their lines were falling, and then this third one has a positive slope, so the line is rising, and that is correct. If we look at number 4, it should have a positive slope. The line is rising, and it looks like number 3. So let's see what happens when we look at number 4. We're going to find our y-intercept. Where is it crossing the y-axis? And that happens right here at 3. So my b is 3. And then I'm looking for any points that are crossing perfectly. I see one here. And it's the only one that is quite perfectly on an intersection. So if you look right here, it's not perfectly on an intersection. You kind of see when you zoom in better there. So we're going to count up from this point. So 1, 2, 3, 4, 5, and over 1, 2, 3. So our slope goes up 5 and over 3. 5/3 does not simplify. We can't divide 5 by 3. So we're just going to keep it as that fraction 5/3. And then we'll write our equation because we have both m and b. Y equals m x plus b. So y equals 5 over 3x plus 3. Next, we need to be able to write an equation of a line given other information. So we're going to use what's given to write the equation in slope-intercept form. So it's the same form we've been using. It's going to be y equals mx plus b, where m is the slope, and and b is the y-intercept. So number 5 says we have a slope of 2 and a y-intercept of 15. So an m of 2 and a b of 15. So y equals mx plus b, y equals mx plus b. So y equals 2x plus 15. Number 6 says a slope of negative 1/2 and a y-intercept of negative 7. So an m of negative 1/2 and a b of negative 7. So y equals mx plus b. Y equals negative 1/2 x plus a negative 7. So this is plus negative 7, which is the same thing as just minus 7. So whenever you have a negative y-intercept, it's going to look like minus that number on the end there. Now on numbers 7 and 8, they're giving us the letters already. So we're going to jump straight into writing our equations. So we have m equals 1 and b equals 0. So y equals mx plus b means that I have y equals 1x plus 0. Do I need to write plus 0? No. Do I need to write 1x as 1x? No. So both of those things are implied. 1x is the same thing as x. Plus 0 is the same thing as nothing. So writing nothing would imply plus 0. So I know that's a little confusing, but like I said, I wouldn't tell you that I had $3 plus $0. So we're not going to add anything onto it. We're just going to leave it out. So I'm going to rewrite that as y equals x, and then I'm not going to write anything on the end there. So y equals x is my equation, and this is actually the linear parent function. So all of my functions stem from this one. Y equals x. It goes straight through the origin, and it has a slope of 1. Now number 8, we got the same type of problem where they're giving me both my m and my b straight just with those variables. So I'm going to go straight into writing it. Y equals m negative 2 x plus b, and like we said on number 6, if it is a negative b, we say minus b. So minus 3. Let's move on to the second page, and this is point slope exploration. So we have our slope formula, which is y2 minus y1 and x2 minus x1. And then we have point slope formula, y minus y1 equals m times x minus x1. I love point slope. Like, point slope makes my heart happy because it's something that you can use in geometry, in Algebra 2, in pre-calculus, in calculus. It's something that you can use in every class after this, and so is slope-intercept form, but point slope is going to get you a little bit further in all of those classes. It's also on your star formula chart. So it's not something that you have to memorize. You don't have to know y minus y1 equals m, x minus x1. It's not something you have to know off the top of your head. It's always going to be given to you. So it is a lovely formula that you can always use to find your equation of the line. So if you were given a point and a slope, you can write the equation of the line. So before we were given the point and we were given the y-intercept every time, and we knew that we could just say plus b. But sometimes you're going to be given a random point that's on the line, and you're not going to know what the y-intercept is. So we'll solve for y to put it into slope-intercept form, which is the one we're used to. So we're going to write the equation in both point-slope form and slope-intercept form. So I have this line that goes through the point 1, negative 2 with a slope of 3. So I'm going to use that point slope formula. y minus y1 equals m times x minus x1. With that point 1, negative 2, this is x1 and this is y1. So we're going to label our points. We have our m, we have x1 and y1. So I'm going to plug these in. Y minus negative 2 equals m, which is 3, times x minus 1. So that's my line in point slope form. And remember, it says to write it in both point slope form and slope intercept form. But this right here can be rewritten. Minus negative 2 is the same thing as saying plus 2. So I'm going to rewrite it as y plus 2 equals 3x minus 1. And so that would be one of my answers. This is my line in point slope. But then I have to solve for y to put it in slope intercept. So I'm going to distribute that 3. I'm going to get 3 times x, which is 3x, and 3 times negative 1, which is negative 3. And I'm solving for y, so I need to subtract 2. And y equals 3x minus 5. And I see that it looks like y equals mx plus b. Everything's away from y, so that is my slope-intercept form. So if you're given a point and the slope, then you can easily find your line equation in slope-intercept form by solving for y from point slope. So this is point slope, and this is slope-intercept. Now in example 2, it's the same type of problem. We're given a point and we're given the slope. So my point, negative 3 and negative 4 are my x1 and my y1. X and y are going to remain variables in my equation. So y minus y1, y minus negative 4 equals m, which is negative 1, x minus negative 3. So I see minus negatives on both of them, so I'm going to change those to plus, both of them. So y plus 4 equals negative 1, x plus 3, and that is my point slope. And then I'm going to solve that for y, so that way I can get my slope-intercept form. So y plus 4 equals, distribute that negative 1, so negative 1 times x is negative x. Negative 1 times 3 is negative 3. Subtract 4. We get y equals negative x minus 7. Once everything is away from y, that is my slope-intercept form. Alright, I'm so sorry about that interruption. The phone was ringing. Okay, so we just found on example 2 that our slope-intercept form was negative x minus 7, and we found our point slope form was y plus 4 equals negative 1, x plus 3 in parentheses. So now we're on to example 3. We have our point negative 3, negative 5, and our slope is 1, 3. So we're given a point, we're given our slope, so we're going to use point slope form. Our point, negative 3, negative 5, is x1 and y1. So we're going to have y minus y1 So y minus negative 5 equals m parentheses x minus x1. So just like in example 1 and 2, I see that I have minus negative, so we're going to change those to plus. So y plus 5 equals 1/3 parentheses x plus 3. That's my point slope form. And then we're going to solve that for y to get our slope intercept. So y plus 5 equals, we'll distribute that 1/3. So 1/3 times x is just 1/3 x. And 1/3 of 3 is the same thing as saying 3 divided by 3, which is 1. So we'll have plus 1. Remember, I want to get y by itself, so I'm going to subtract out that 5. We get y equals 1/3 x minus 4. Once everything's away from y, whoops, then we have our slope-intercept form. And now example 4. We have our point, we have our slope, so we're going to use point-slope form. -4, -2, that's my x1 and my y1. So y minus y1 equals m parentheses x minus x1. So now I have double negatives. This won't happen every time. So we saw on example 1 that it only happened with the y, and then on each of these other examples it's happening both times. Sometimes it won't happen at all. It just depends on where your negatives are. So on this case we have both negatives, so we're going to have to change both of them to positive since we've got minus a negative. So y plus 2 equals -1/2 parentheses x plus 4. That is my point slope. And then I'll solve that for y to get my slope intercept. Y plus 2 equals, and then I'm going to distribute. -1/2 times x is -1/2 x. And then we've got -1/2 times 4, which is the same thing as saying, what is half of 4? Which is the same thing as saying 4 divided by 2. 4 divided by 2 is 2. So we have -2. We're going to get that 2 away from y. So we're subtracting 2. Y equals -1/2 x minus 4. And then that's our slope-intercept form. So see, we were able to find slope-intercept when we were given a random point on the line and the slope. Now on 5, 6, and 7 it says write an equation in point-slope form for each line. So point-slope is not the one we're used to. Now this is y minus y1 equals m x minus x1, where y1, x1 come from a random point on the line that is not my y-intercept. So if you look at each of these, they have random points picked out. So we have this point here and this point here, and I see that neither are my y-intercept because my y-intercept is occurring somewhere that I can't necessarily pick out. So this comes in handy when your y-intercept is a fraction and it's not easy to pick out from the graph. So my x1, y1 is going to come from the first point. It doesn't really matter the order because we're going to be subtracting either way, so we're going to end up with them in the right order technically. It's going to get really It's not going to get complicated. It's just that I don't want you to overthink what order am I going in. So pick a point. I like to go left to right. Okay, so on each of these examples, you're going to see me go left to right. So my first point will be the leftmost point. So it's this one right here, which is at -2, -1. And then my x2, y2, my second point, is at 1, 3. So I'm going to do this two different ways. If I were only given these points and not the graph, I'm going to write down here, I would have to find my slope. So slope, let me make this smaller. Slope equals, and this was at the very top of this page. Let me show you. Right here, y2 minus y1 over x2 minus x1. So I'm going to use the slope formula to show you how I would get m. So both of those points I have. So y2 is 3, y1 is -1, over x2 is 1 minus x1, which is -2. So all I did was plug in my points into that equation, and I labeled them in the purple right above it. I see minus negative on both of them, so I'm going to rewrite that. 3 plus 1 over 1 plus 2. 3 plus 1 is 4, and 1 plus 2 is 3. So my slope is 4 over 3. And so when I'm writing my equation in point slope form, it doesn't matter which point I pick. So I'm going to pick the first point. Actually, I'll pick the second point so I can show you what it looks like when we're dealing with both positives, since on examples 2, 3, and 4 we had both negatives. So we're going to look at the second point for my equation. So this is y minus 3 equals 4/3, my slope, times x minus 1. So when you're dealing with both positive, you see you don't have that double negative in there. So you could stop here, and this is your line in point slope. Now another way that I could have done this, since I was given the graph and those 2 points, is I could have counted my slope. So I could have said, how many am I rising? 1, 2, 3, 4. How many am I running? 1, 2, 3. My slope is 4 over 3. So we see we end up with the same slope whether we use the equation or we use the graph. Now let's do number 6. We have both of our points picked out for us here. We got one here and second one here. So x1, y1 is the leftmost point for me. So we're going to say -3, and it goes up to 4. So -3, +4, and our second point, x2, y2, and that is 1, 1. So I'm going to use the slope formula again, just so we can get some practice using it. y2 minus y1, so my second y minus my first, and then x2 minus x1. So y2 is 1, y1 is 4, and then x2 is 1, and x1 is negative 3. I see a double negative, so I'm going to rewrite that as plus. So I have 1 minus 4 on the top, and then on the bottom, 1 plus 3. 1 minus 4 is negative 3. 1 plus 3 is 4. So my slope is negative 3/4. And then for my equation, I'm actually going to write it down here. Y minus y1, y minus 4 equals m, negative 3/4. I'm picking the first point to work with. And then x minus x1. I see a double negative, so I'm going to change that to plus. Y minus 4 equals negative 3/4 x plus 3. And so this is my point slope form. And then we'll do the same thing on number 7, but this time I'm only going to use the graph. So I'm not going to use the slope formula, just so we can see the difference in what we would do. So on number 5, we did both ways. On number 6, we only did slope formula. And on number 7, we're only going to do from the graph. So my first point is here. My second point is here. So x1, y1, the first point, is negative 1, 2, 3, negative 1. Second point, x2, y2, is positive 1, positive 2. My slope, I'm going to get from counting. So from first point to second point, I'm going up 1, 2, 3. And I'm going over 1, 2, 3, 4. So my slope is 3/4. So now when I'm writing my equation, y minus y1, negative 1, equals m, which is 3/4, x minus x1. So we have double negatives on both of those, so I'm going to change them to plus. Y plus 1 equals 3/4 x plus 3. And that's my point slope, so I'm done there. So we did that without using the slope formula, we just counted on the graph. And so those are the different ways to write our equations given different information. And this was day 1 of writing equations.